We have a random variable x that follows a uniform distribution between -3 and 5. Now I've drawn out the probability density function for this random variable x. We can have increasing values of x along the horizontal axis, and the vertical axis represents the probability density function. Now the only thing that we've not added into this diagram is the height of the probability density function. Now remember, a probability density function is well defined if two conditions are met. Firstly, the probability density function is always greater than or equal to 0, and the second, that the area under the probability density function is equal to 1. So we've got a uniform distribution or a rectangular distribution that's non-zero between -3 and 5. So that's a width of 8. So in order for this rectangle to have an area equal to 1, it must be the case that the height of the rectangle is equal to 1/8. So our probability density function is going to be 1/8 between -3 and 5, and it's going to be 0 otherwise. Now, we can use this probability density function to calculate the expectation and then subsequently the variance of our random variable x. So remember, for a continuous random variable, the expectation is just equal to the integral between -infinity and infinity of the observations of x times by the probability density function of x. So we've got three areas to our probability density function for x less than -3, x between -3 and 5, and x greater than 5, and we'll split the expectation into three parts. Firstly, between -infinity and -3 of x times by the probability density function, but the probability density function is just 0 between -infinity and -3. Then we've also got the integral between -3 and 5 of x times by our probability density function, which is just 1/8. And then we've also got the integral between 5 and infinity of x, once again times by 0. Now the first and the final term just vanish because we've got the integral of 0, and we're just left with the integral between -3 and 5 of 1/8 dx. So this is going to be equal to, if we integrate this expression, we're going to have x squared divided through by 16, and we're going to evaluate that between 5 and -3, which is going to be equal to 25, that's 5 squared over 16, minus -3 squared, so that's going to be -9 over 16, which is going to be equal to 16 over 16, or 1. And that gives us our expectation of x. Now we've got that the expectation of x is 1, and we know that the variance of x is going to be equal to the expectation of x squared minus the square of the expectation. Now we know that the expectation of x is 1, so that will be -1 squared. So we just need to find the expectation of x squared, and we'll find that in exactly the same way. The expectation of x squared, all that we're going to do is we're going to take the integral over the full possible range of x of this time x squared times by our probability density function of x. Now just as before, between -infinity and -3, our probability density function is just 0. Between -3 and 5, we have x squared times by 1/8, because our probability density function is 1/8 in that range. And then also we've got the integral between 5 and infinity of x squared times by 0 dx. And just as before, the first and the final terms are just 0. So this is going to be equal to the integral of x squared over 8 evaluated between -3 and 5. So this is going to be equal to, if we integrate x squared over 8, that's going to be, we raise the power by 1, that's going to be x cubed. We bring the new power down to below, so that's going to be dividing by 3, and 3 times 8 is 24. And we're going to substitute in our limits of 5 and minus 3. So if we substitute in those limits, we get this is equal to 125 divided by 24 minus 3 cubed. Minus 3 cubed is minus 27, so that's going to be plus 27 over 24, which is going to be equal to 152 over 24, or 6 1/3. Now this is equal to the expectation of x squared. And remember, if we want to find the variance, we need to take this expectation of x squared and subtract the square of the expectation of x. So the variance of x is equal to the expectation of x squared minus the square of the expectation of x, which is equal to 6 1/3 minus 1 squared, which is equal to 5 1/3. Now, suppose that we randomly sample 2 observations from this random variable x. We call our 2 observations x1 and x2. If we randomly sample an observation from this population, this observation that we've got is itself a random variable. We don't know what it's going to be, and it could take any value in the range -3 to 5, and it will follow the same distribution as the underlying population random variable. So x1 will follow a uniform distribution between -3 and -5, and similarly x2 will follow a uniform distribution between -3 and 5. And so we can write down that the expectation of x1 will be equal to the expectation of x2, which is going to be equal to 1, and the variance of x1 is going to be equal to the variance of x2 is going to be equal to 5 1/3. Now, the other bit of information that we're told is that x1 and x2 are drawn independently from this underlying population x. So that means that knowing the value of x1 is not going to affect the value of x2. And if they're independent, it also means that the covariance between x1 and x2 are going to be equal to 0. So we construct a new variable y, which is just equal to x1 plus x2. And we want to know what the expectation and variance of y is going to be. And in order to do this, we just need to think about some of our rules of expectations and variances. So remember, if you're finding the expectation of some constant multiplied by a random variable, this is just equal to the constant times by the expectation of that random variable. Similarly, the expectation of a sum of random variables is just equal to the sum of the expectations. And similarly, in terms of the variance of any constant times by a random variable is equal to a squared times by the variance of that random variable, and the variance of any sum of random variables is equal to the variance of x plus the variance of y plus 2 lots of the covariance between x and y. So in this case, we've constructed a variable y which is equal to the sum of x1 and x2. Using our rules, we can write down that the expectation of y is just equal to the expectation of our observations x1 plus x2, which is going to be equal to the expectation of x1 plus the expectation of x2, but we know that the expectation of x1 and x2 are just equal to 1, so this is going to be equal to 1 plus 1 is equal to 2. Similarly, the variance of y is just going to be equal to the variance of x1 plus x2. Using our rules from before, the variance of a sum of random variables is equal to the variance of x1 plus the variance of x2 plus 2 lots of the covariance between x1 and x2. But because we're told that x1 and x2 are independent from each other, that means that that covariance term is 0. So we're just left with the variance of x1 plus the variance of x2, which is equal to 5 1/3 plus 5 1/3, which is equal to 10 2/3.